So we are going to talk about how you're going to fill in the unit circle. You will be given at multiple points a unit circle, a blank unit circle that looks like this, and it's your job to fill it in. I tend to do it in 3 different sections. Section 1, I deal with the degrees because that's the easiest in my mind. I know that there's 360 degrees in a circle, and I know that I start here. So that's 0 degrees. And I'm pretty good at the degrees, so I know that the first one is 30, and so I just have to keep on adding 30. But I remember I skipped the middle one, and then it goes 60, and then it turns into 90, and then I add another 30 and get 120, and 150, and 180, and I know that 180 is halfway around, right? And you turn backwards, and that makes sense, so I'm backwards. And then I get to 210, and I add another 30, and I get 240. I make sure I skip that one. And then I add another 30, and I get to 270, right? 270 on and 270 off of rails. And then I get to 300, and then I get to 330, and I get here to 360, and I know I've done it right because I end up getting my full circle of 360. So that should be pretty good. And then we need to do the 45s, and I always do that secondarily, and I'm going to just do it in a different color so we can just see that they're different. So 0, and then 45, and then I add another 45, I get 90, another 45, I get 135, I add another 45, I get 180, and then here I'll get 225. And one of the ways to make sure you're right is to realize that 225 is exactly halfway between 210 and 240. So that's another way to think about it. But I add another 45, I get to 270. I add another 45, and I get to 315. So now my angles are done, or my degrees are done. Next thing I'm going to deal with is my radians. And this is the new part for most of us. So this is the way that my brain thinks about it. I deal with the pi over 6s first. I remember I tell myself that we are going to deal with pi over 6, and maybe I'll do that in a different color. We'll deal with pi over 6, and that's what I'm going to deal with first. So I always start here, and I do 0, and then I have 1 pi over 6, and I have 2 pi over 6, which I can reduce to pi over 3. Right? Maybe I said that. 2 pi over 6. This one here is 3 pi over 6. 4 pi over 6. 5 pi over 6. Notice I'm just counting. 6 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. And then this is 12 pi over 6. All right, so I've written all those down. Some of them we can reduce, so we need to go back through. To get full credit for this, you need to go back through and make sure that you have the reduced forms. I don't care if you actually erase them, so I'm not going to erase them. I know that 3 pi over 6 is the same as pi over 2. I know that 4 pi over 6 is the same as 2 pi over 3. Whoops, that's not a 3, that's 5 pi over 6 is reduced. 6 pi over 6, well, that's just pi. 7 pi over 6, 8 pi over 6, I can reduce that to 4 pi over 3. 9 pi over 6, again, I can reduce that, pardon my vertical equal sign, but to 3 pi over 2. They're both divisible by 3. 10 pi over 6, well, that's the same as 5 pi over 3. 11 pi over 6, and then 12 pi over 6 is the same as 2 pi. So those are done. Next, and lastly, I'm going to do the pi over 4. So I'll do that in another color. I'll do that in green. Put a little note to myself, pi over 4. So I start here again, 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4. Notice I'm counting. 4 pi over 4, 5 pi over 4. And I also want to point out, like 4 pi over 4, I ended up in the same spot, so I know that I'm on the right road. 5 pi over 4. This must be 6 pi over 4. I could reduce it, so that works out. This one here is 7 pi over 4, and then I get to 8 pi over 4, and I know that that is just pi over 2. So that's how I deal with the radians.